There is a side of the moon that no human being on Earth has ever seen with their own eyes. Not once in all of recorded history. And the reason why is one of the most elegant and slightly terrifying mechanisms in the entire universe. It's called tidal locking, and once you understand it, you'll never look at the night sky the same way again. Here's what's actually happening. The moon is not stationary. It is rotating on its own axis, just like Earth does. But here's the thing, it rotates at almost exactly the same rate that it orbits around Earth. One rotation, one orbit. They match perfectly. And that is not a coincidence. That is physics doing something extraordinary over an enormous stretch of time. About 4.5 billion years ago, when the moon first formed, likely from a catastrophic collision between early Earth and a Mars-sized body scientists call Theia, the moon was spinning much faster. It completed a full rotation in just a few hours. But Earth's gravity is not uniform. It pulls slightly harder on the side of the moon closest to us. This creates what physicists call a tidal bulge, a tiny but real deformation in the moon's shape, a stretching effect caused by differential gravitational force. Because the moon was spinning faster than it was orbiting, that bulge kept getting dragged slightly ahead of the Earth-Moon line. And Earth's gravity kept pulling that bulge back. Like a brake. A slow, relentless, gravitational brake. Every single day, for billions of years, the moon's rotation slowed down by an almost immeasurably small amount. Physicists at the Massachusetts Institute of Technology estimate this process, called tidal dissipation, bleeds energy from the system continuously. The energy doesn't disappear, it converts into heat deep inside the moon's interior and into a very gradual increase in the moon's orbital distance from Earth. In fact, the moon is currently moving away from Earth at a rate of about 3.8 centimeters per year. Laser ranging experiments using reflectors left by Apollo astronauts in 1969 have confirmed this with extraordinary precision. Now back to tidal locking. After roughly 1 billion years of this gravitational braking, the moon's rotation had slowed to exactly match its orbital period, about 27.3 days. At that point, the tidal bulge was no longer being dragged forward. The system reached equilibrium. Stable. Locked. The same face of the moon now permanently points toward Earth. Scientists call this synchronous rotation. And the moon is not alone in this situation. Pluto and its moon Charon are mutually tidally locked, they both show the same face to each other at all times. Mercury is in a special 3:2 resonance with the Sun. Many exoplanets discovered by the Kepler Space Telescope orbiting close to their stars are almost certainly tidally locked, meaning one side bakes in eternal day while the other freezes in permanent night. The far side of our moon, finally photographed for the first time by the Soviet Luna 3 spacecraft in October 1959, looks dramatically different from the near side. It has far fewer of the dark volcanic plains called Maria and a much more heavily cratered surface. Researchers published findings in the journal Nature Geoscience in 2016 suggesting this difference may relate to heat from early Earth keeping the near side's crust thinner and more volcanically active. The practical takeaway here is this: tidal locking is not rare. It is the inevitable fate of almost any sufficiently close moon planet or planet-star system given enough time. Earth itself will one day become tidally locked to the moon. In approximately 50 billion years, the Earth's day will stretch to match the lunar month. Of course, the sun will have consumed us long before then. But the universe plays a very long game. Every time you look up at that familiar face of the moon, you are seeing the direct result of 4.5 billion years of gravitational sculpting. The universe is not random. It is ruthlessly, beautifully mechanical.